In this video, we're going to talk about list. So linked list. Linked list is an alternative data structure to the arrays where they can store multiple values together like array, but there's like more flexibility. Refer to the notes why the linked list is better. Okay, so in this lecture, in this video, we're going to focus about how linked list works. Okay, so linked list look like this. So basically, multiple lists are linked together using the arrows. Okay, so here the arrows means what? It's using pointer. Okay, so let's think about example. So how do you represent this one? Well, first, you need to have a type to represent each node. Okay, so the type for each of the node at least has to be what? Struct, right? Because it contains what? Two things. First is what? Value, 3 or 7. And second element, second member is what? Arrow, pointer. Okay, so usually we call that as struct node. Okay, so let's define this struct node. Struct node. And it has what? First element. You should give the name. I'll just give name data. The type of data is integer. And then now, what should be the type for this arrow stuff? It's a pointer. It points to what? Another node, another struct node. So that means type of that second member is pointer to the struct node. And then usually, because it's pointing to the next node, the name is next. Okay, so that's how you define struct node. Okay, now let's think about main function. Okay. Now you should have what? L, right? And then L is what? Pointing to a node. So how do you make a node? Use callo. And then how many nodes? In the list, you create one node by another node, one node by another node. So just only one. So callo of 1 means what? Array of size 1, meaning just a node, a single node. The size of the array of size 1 was each element is basically struct node. That's how you allocate a node in the heap. Okay. And then what do? You follow the arrow. How do you follow the arrow? Right. So L.data is this one. Okay, this one is what? L.data. Okay. Not dot. Use arrow. L arrow data because L is the pointer, right? L arrow data, and then you set 3. Okay, and then now let's think about this one. Okay, this one is what? L arrow next, right? That has to be what? Pointing to another node. So that means what? We have to allocate like this, right? Makes sense? So now that's good. Now we have to do another stuff. This one. Sorry. you have to do this one. How do you access that? This is L, and then follow the arrow, and then this is L next is green, and then this is the pointer, so follow that, and then access the data in the next node, and then you send 7. Okay, so what is this last one? The last one is what? L next. And then this, what? 5 on the line means what? Is null pointer. So usually null pointer means what? It's done. And there's no next node. So it's the convention that you put null pointer for the last node of next, for the next member in the last node. Okay, so that's good. So we created. So now let's think about adding one node in the front of the list. Okay, so now how do you do that? So I'm gonna create a new array. Especially, I'm gonna make new function. So it's returning modified list after adding a node in front. Of course, the input is what? Original list, and then you should have value to set in the newly created node. So here, I'm gonna use the function addfront, and then I'll just have what? 0 element. So let's define this one. So how do you define this one? Well, what should happen is this. So you should make a new node. Right? And then, well, to do that, you should have callow, and then have some pointer variable. Let's say t is the pointer variable. So t, and then callow, and then size of. Okay, and then you set the value to here. Okay. So that means what? T arrow data has to be value. Right? Makes sense? That's what it is. Then what? Now you should do this. Right? Why? Because I want this, let's say, no, this is 0, because we call that function with 0, because this node has to be the first node in the list. So that means what? You have to set t next to be pointing to this node. So how do you make sure? Where is that information? That information is in here. So because L points to the first node, and what that means, what the value of L is really the address of the first node, right? So you do that. Okay. Now, what do you return? Return this one, return the address or return what t points to. So return t. T is the pointer, right? So now when this is returned, this line is returning what t points to, right? The address of the first node, address of the newly created node. So now this assignment, L equals add front assignment operation, okay, will make sure to this. Right. So now look at this. L points to 0 node, and then next is 3, and then next is 7. So that's what we wanted. Right. So now if you call or add this, okay, so that means the list should be now what? -1 is the first, and then 0, 3, 7 is also original. Okay. So let's verify that. So let's print. How do you print the first node? Well, first node is what? You gotta use L and then follow the arrow, right? So L. How do you access the next node? Use the L next to actually followed to access the second element, and then use another arrow to access the data using the same logic. And then so remember, what do we have? We should have -1, and then 0, and then 3, and then 7 should be what's stored in the list. Okay, so yep, -1 and 0, 3, 7.